All right. Hello there. Oh, sorry about that. We're going to deal with infinite geometric series, and that means we're talking about trying to find the sum, but we're saying, okay, we're going to keep going until we've put in an infinite number in. So it may be finite or not. So here's how we tell. Right now we know the rule is 2. So what would happen if I kept multiplying by 2 over and over? Notice the series, as we look at all the numbers, it would eventually, right, 2 to the infinite power is going to give me infinity. This is going to go to infinity, right? We call that diverges. All right, what about this one? This time, r equals 1/5. Okay, so what's going to happen over time is our numbers are going to get smaller and smaller, right? So we got 1/5. We're going to take it times 24, 1/25, 1 over 125. So it's going to keep getting smaller and smaller and smaller. So eventually, we're actually going to get closer and closer to 0 as far as what we're adding on, which means we're going to be kind of close to some number, so it converges. So this is the only thing that we're going to have to deal with is when r is less than 1, or it converges. That's the only time we're going to do what we're going to do next. Now, we don't really care if it's positive or negative when we talk about less than 1. So that's why we'll see on the next slide here that we're going to deal with when r is between -1 and 1. Notice it is not inclusive. So if it was 1, that wouldn't change anything. All right. Then we're going to use this formula, which we're pretty close to familiar with. So this is based on an infinite geometric series. So that means that that summation has infinity on the top, or we can use the regular s. Right? Instead of trying to find a number, we may put infinity in here. Okay, so r is the common ratio, a sub 1 is the first term. So those are the things we're used to dealing with anyway. Find the sum of the infinite geometric series if it exists. So in our first one, we have to find out is what's the r value. Well, r, remember we were told that these are geometric series. So how am I getting here? Multiply the top by 3 and the bottom by 4. Make sure that works. 3 times 3 is 9. 8 times 4 is 32. So I have 3/4. Okay, so that means I should go ahead and follow my formula up top. A sub 1, 1/2 over top of 1 minus 3/4. Just plugging everything in. I'm going to work to the left here. So I have 1/2 over 1/4, which means that we're eventually going to do 1/2 divided by 1/4. We're going to do 1/2 times 4 over 1. So we got 2. 2 is going to be the sum as we take this infinite geometric series the whole way to infinity. I think we jump right into something that was a little bit tougher. So hopefully, if you have any questions, we can follow up in class. All right, next one we have is how am I getting 1/3 to turn into 1/2? Well, r happens to be 3 over 2. Right, 3 times 3, or 1 times 3 would give me 3. 3 times 2 would give me 6, so it becomes 1/2, so 3/6. So remember, we're going to work backwards if we need to figure that out by doing 1/2 divided by 1/3. So that's 1/2 times 3 over 1. So that's how I'm getting 3 over 2. If r is greater than 1, 3 over 2, then this is divergent, and we get to stop right there because it diverges. All right, the next one that we have, how do we get from 1 to -2? Well, r has to be -2. -2 to get to 4, +4, it's going to be negative again. And again, our value is outside of -1 to 1, so this is divergent, so we don't have to do anything with it. So of course, the next one, I see the numbers are going down, and that means r has to be 1/2, right? I don't think this one's too tricky to figure out. 1/2. which means we're going to practice that formula again. Let me move that up so I can show you where this is coming from. A sub 1, 1 minus r, a sub 1, 20 over 1 minus 1 half. So I get 20 over 1 half. So that means we're going to do final answer of 40. So the sum of this sequence going the whole way out to infinity, if we could get the whole way there, would be 40 if we added all of them up. Kind of crazy when you think of it that way. All right, the other setup that we have is summation. So here we're saying the sum from the first term to the infinite term. So this is your key to know that you're dealing with an infinite geometric series. Here's our key for geometric. This means r is 1/5. And the only difference here is we don't really know what the first term is. So that's the only trick, is we do have to plug 1 in here to find out that a sub 1 is 24/5. So you get 24/5 over top of 1 minus 1/5. So we get 24/5 over top of 4/5. All right, and we'll do our calculations. 24/5 divided by 4/5, which means 24/5 times 5/4. So the 5's cancel. 24 over 4 reduces into 6. Okay, so that means if we take this sequence and we go the whole way, add them all up, the whole way out to infinity, if we could get there, it converges onto 6. That is the number that we get. Not too shabby. All right, one more. This one has the negatives just to show you what's going to happen. First things first, we got to find out what a sub 1 is. So I'm just implying that you're with me here. R is -3/4. Right, there's no change in anything there. So we're going to plug in 1 for the first term. 1 minus 1 is 0. Anything to the 0 power is 1. 1 times 16 is 16. So here's what we have. We have 16 over top of 1 minus -3/4. We have 16 over, remember that turns into plus. So at this point, we may change it to 1.75 just to work with a calculator a little bit easier if you want to. And that means we're going to be about 9.1428. Okay, so I just want to make sure we threw 1 in here, that it's not super duper fantastic, but we can work with it. If you want to leave it in fraction format, I'm cool with that too. All right, the last page is really just review. I know this is one thing that sometimes we struggle with, so I'm going to make sure that I cover this one more time in case you need some help with it. All right, so this is for a particular number of terms, not for infinite. So this is going back just one day in case you have any questions. You see our formula up top there. We want the sum of the first 17 terms. That means n is 17. Some other things we know, a sub 1 is 2, and r happens to be 2. How do we get that? I have to multiply by 2 and multiply by 2. Okay, so we can drop everything in here. So a sub 1 is 2. We have 1 minus r is 2. We want that to the 17th power. It's over top of 1 minus r is 2 again. So I have 2, and here we're going to do 1 minus whatever 2 to the 17th power is. Then take it times 2, and we're going to change that back into divided by a negative. All right, so calculator work from here. So final answer, 262, 142. All right, we're going to find the sum of the series this time. Notice it's not infinite. We're showing that it does stop at some point. So we have a couple things we have to do. We have to figure out how many term numbers we are after here. So it has a little bit of back work since that is review, and I don't want this video to go too long. Remember, we're dealing with number 12. R is 1/2. A sub 1 is 160. Okay, so the 12 comes from setting up our formula. We know this is 1/2, and we're trying to find out the power. Okay, so this is going to give us our 12. After that, we're able to plug everything in. 160, 1 minus 1/2. We need to take that to the 12th power, and then it's over 1 minus 1/2. Again, to save you some time for here, as long as we get 319.92, we're in good shape. Otherwise, we need to check out some time together and make sure if you need some help. All right, thanks for checking it out. Good luck. Let me know what your questions are.